Let us consider transformation of the form g of x equals f of x plus k. To understand this transformation, let us consider one particular example. Let us take f of x equals x square, which is a parabola. Let us take k value to be equal to 1. You can explore the same concept by considering different functions. As if now, let us consider f of x to be x square. Then we get g of x to be equal to f of x is x square, g of x is f of x plus k. So very clearly we replace x by x plus k. Hence we get it to be equal to x plus k the whole square, and in this case what we consider is k equal to 1. So we get g of x equals x plus 1 the whole square. Let us consider the curve f of x. We know that f of x is a parabola. The parabola passes through the points 0, 0, 1, 1, 2, 4. Since it is symmetric, we get points minus 1, 1, minus 2, 4. Let us plot g of x now. For various values of x, 0, 1, 2, let us see what are the values that we get for g of x. When x equals 0, we get 0 plus 1 the whole square, which is 1. For x equal to 1, we get 1 plus 1, 2, 2 square, 4. For x equal to 2, we get 2 plus 1 the whole square, 3 square, which is 9. That is 0, 1. For x equal to 0, we get y equal to 1. For x equal to 1, we get y equal to 4. For x equal to 2, we get y equal to 9, somewhere on top. Now, let us consider few other values to get clarity on this. Let us consider x equals minus 1. For x equal to minus 1, what do we get for g of x? Minus 1 plus 1, which is 0, 0 square, 0. So we have minus 1, 0 to be a point on g of x. What happens if x is equal to minus 2? For x equals minus 2, we get minus 2 plus 1, which is minus 1, minus 1 square, 1. For x equal to minus 2, we get it to be equal to 1. What happens if x is minus 3? Minus 3 plus 1, we get it to be minus 2. Minus 2 square, we get it to be equal to 4. So for x equals minus 3, we get y value to be equal to 4. X equals minus 3, we get it to be equal to 4. Let us join. Now if you want, you can find one more there. For x equals minus 4, minus 4 plus 1, we get it to be equal to minus 3, and minus 3 square, you get it to be equal to 9. So we get it to be equal to 9. 4 minus 4, you get it to be equal to 9. So let us join this now. We get this to be the curve. This is the function f of x, and this is the function f of k plus 1. See the shift. The parent function f of x is shifted, translated horizontally. So you can clearly see it got translated horizontally to the left side by 1 unit. Let us consider k value to be equal to -1 now. So g of x becomes x minus 1 the whole square. Let us explore that. So let us consider -3, -2, -1, 0, 1, 2 and so on for the values of x. Now when x is equal to -3, g of x becomes -3 minus 1 which is -4, -4 square which is 16. So when it is -3, we get it to be equal to 16 somewhere on top. -2. -2 minus 1, -3, -3 square 9. So for -2 we get it to be equal to 9 now. -1, -1 minus 1, -2. -2 square you get it to be 4. For -1 you get it to be equal to 4. You can clearly see these are the points on the curve. For x equal to 0 we get 0 minus 1, 1 minus 1 square 1 we get. So for x equal to 0 you get it to be equal to 1. For x equal to 1 what do we get? 1 minus 1 0, 0 square 0. So for x equal to 0 you got it to be 1. For x equal to 1 you got it to be 0. For x equal to 2, let us consider 2. Let's see what we get. 2 minus 1, 1. 1 square, 1. For x equal to 2, we get it to be equal to 1. For x equal to 3, what do we get? 3 minus 1, 2. 2 square, 4. 4, 2. For x equal to 3, 3 it is 4. You can clearly see that. See, these are the points. Let us join them. So this is the curve f of x minus 1. That's the curve f of x minus 1. Observe these curves. When f of x changes to or transforms to f of x minus 1, we see that this is a horizontal shift, a horizontal translation. By how many units? By 1 unit. When f of x transforms to f of x plus 1, f of x transforms to f of x plus 1, we see again that it is a horizontal shift. It is a horizontal shift to the left by 1 unit. Let us try to generalize it. F of x when it transforms to f of x plus k, f of x plus k. What kind of a transformation we observe? We see a horizontal translation. We see a horizontal translation. Now this translation, the curve get translated to the left side if k value is positive. So it is translation to the left. It is translation to the left if k is positive, and it is translation to the right if k is negative. It is translation to the right side if k is negative. I would like you to explore the concept, the idea of horizontal translation by considering different functions. Or for the same function you consider different values for k. Consider k is equal to 2. Consider k equal to -2 and see what happens. You will observe the same kind of phenomenon. And you can consider different values, different functions. Consider f of x equal to an exponential function e power x. And change x to x plus k for various values of k and observe, analyze. You will see that whenever f of x, whatever be the function, when f of x transforms to f of x plus k, you end up getting a horizontal translation. The curve moves or translate or shift to the left side if k is positive. It translates to the right side if k is negative. Thank you.